Thank you all for having me. Thanks to Pragma for having me here, especially. My name is Conor. I'm a software engineer at Spotify. And this talk is very creatively titled Continuous Delivery at Spotify. So what is that going to contain? If anybody saw Martin's talk earlier about Swisscom, he stole pretty much all of what I had to say. So I'm going to say the rest. I want to talk really about three main things. First, I want to talk about how we organize dev teams at Spotify, like how we set our teams up so that they are free to deliver as fast as they want to and free to to succeed, pretty much. Also, I want to talk about some of the history we have since Spotify was created in 2006. We've grown a lot since then, and the tech has grown a lot as well since then as well. So I want to talk a bit about how that happened over the years. And finally, I want to talk about some of the cool parts of the continuous delivery pipeline that we use in my team. And I'll give you an idea of what we do to ship things as fast as possible. I'm not going to try to recommend any specific products or anything, and I'm not going to try to sell you anything, because I'm sure you all have Spotify already. So first up is how we organize our team. So as Martin said, he talked a lot about the structure of how Swisscom used this sort of Spotify model that people call it. And what I want to focus on specifically about that is autonomous teams. So at Spotify, we have a very big culture of teams are autonomous. They get to decide a lot of things themselves. And there's a couple of different aspects of what an autonomous team is. The first part is that a team will have a very well-defined mission or objective. It'll be very clear what the team's goal is, so that they can focus on that exclusively. And second, follow-up to that is that they have all of the right people that they use to work on that focus or mission for the team. So if your team is a purely back-end focused team and you work on optimizing databases or something, then you're going to have lots of back-end engineers, maybe some database experts or something. But conversely, if the team is, for example, the team that works on the playlist view in the app, maybe then you want an Android engineer and an iOS engineer and maybe a back-end engineer as well, and some data people too. So basically, we just have all of the right people in the team so that the team can work enclosed, autonomously on whatever the mission is that they have defined for the team. Next, we have team ownership and responsibility. So if you work on a number of systems in your team, you completely own and are responsible for those systems. So that means things like you are responsible for provisioning machines for it, you're responsible for the health of the machines for your systems, you're also responsible for the direction that they're going to go in the future, how the tech's going to progress, and also being on call for them. And the final part, and I guess the most important part for this talk, is that teams have autonomy over the tech that they use. So if you want to write a system in a particular way, you're completely free to do that. If you want to use Scala maybe instead of Java, if you have a good reason to do that, sure, then you can do that. And this doesn't necessarily mean that everybody does this. You might think if everybody has autonomy over tech, then every team is going to want to write things in whatever fancy language that they feel like that day. But that's not true, because as developers, we're inherently lazy. So if you see a service that somebody has built already and it's very well documented and the frameworks that they use are very clear, then you're going to want to copy that as much as possible so you can start working on the stuff that you actually want to deliver, which is the features of the service. So what actually happens is that we have a thing called a golden path. So if you want to spin up a service really quickly, you can just follow this golden path, and then you get a Java backend service with metrics and a CD pipeline and everything really, really quickly. And that's pretty much what everybody tends to do. But if for some reason that doesn't fit the needs of your team, or you want to do a little bit extra or veer off the path slightly, you're totally free to do that. But it will require a little bit extra work, of course, because maybe the path you're going on hasn't been as well traveled as the one that most people go on. But this also means that we don't have any dedicated ops teams. we do all of the ops ourselves in the team since we're responsible for all of the services that each team owns. Then you're also responsible for being on call for those services and for maintenance and for the general ops of those services and for setting up the CD pipelines. And the reason I'm talking about this is because it allows us as a company to optimize the CD strategies, etc., that we use for the domain that a team works in. So if you really, really care about iterating really quickly and deploying things really quickly, you can configure your tech and your CD pipeline to do that. But if you're more, if that's not as much of an issue for you, then maybe your focus should be elsewhere. Yeah. So next, I want to talk about a little bit of history of how we got here. So for those of you that don't know, Spotify was created in 2006, and back then it was very much like a super like startup culture, like move really fast and don't care so much about maybe the continuous delivery or the tech because we don't have any users yet. So that's most important. So back then it was this was like before we had containers or anything like that. So everybody ran Debian on their workstations. And if you wanted to build a service, you packaged it into a Debian package, then you SSH'd into the server you wanted to deploy it on, and then you manually installed it, like apt-get install my service, for every server you want to do that on. And of course, like this is a super small company, so the server you're deploying it on is probably like sitting beside you on your desk, or like keeping your feet warm or something. And then moving on to 2010, it's only 4 years later, but now we have a bit more users, so things are starting to get more serious. We're still not as big as we are today. Like the US launch hasn't happened yet, for example, so it's still mostly happening. Stuff's still mostly happening in Europe. We're still using Debian packages for packaging and for installing things, but at least now we have some deployment infra for it because we are more people and manually installing things doesn't scale. We have manual machine provisioning in 2010. So if you want to get some new machines, if you need to scale your service, you maybe write a little form or something and try to like buy more machines, manually install everything on them, and then get them set up. And it might take a couple of days. But we had DevOps in each team then as well. I mean, it wasn't really called DevOps then, but it was pretty much the people who were working on the services were also responsible for maintaining the machines and maintaining the whole life cycle of the deployment for those services as well. And I said also that we have microservices everywhere back in 2010. So this sort of just happened naturally. I don't have any like war stories of splitting a monolith or anything. There's some really good ones out there. But it just sort of happened naturally. The way we organized the teams meant that people were focused on what they were focusing on, and they started building things in a microservice architecture quite naturally. On to 2014. Now Spotify is like a proper global company, and the tech is starting to reflect that a little bit. So we've joined the container fad, and we have containers everywhere to package and deploy services. We also have, in 2014, automatic machine provisioning in our data centers. So if you have a service that's running out of capacity, or you need to do some capacity planning for it or something, then it's just a matter of filling out a form or filling out like a web UI, and then you immediately get new VMs, and they're all automatically configured using Puppet. So you automatically get whatever packages you want on the machines when you provision them. Also, we switched to GitHub Enterprise in 2014 as well. So, I mean, we were a little bit late joining that party, but basically what that gave us was like fancy pre and post commit hooks. So now we could like trigger builds immediately like through GitHub, and everything was much cleaner that way. But finally, we started using something called Helios for container orchestration and deployment, and we also made it open source as well. So back in 2014, it was a bit of a Wild West when it came to container orchestration platforms. Every company was making their own container orchestration platform and open sourcing it, and Spotify was no different from that. So we built Helios to manage our containers and to deploy them onto the machines post-commit. And we open sourced it actually on the same day that Kubernetes was announced. But now it's pretty clear who won that little race. Not that it was a race at all. So moving on, we're starting to move away from Helios now onto like what's more industry standard. And that brings us to 2018. So like I was just saying, Kubernetes is now like industry standard when it comes to container orchestration. So we're switching from Helios into that slowly. We've also moved off on-premise data centers as much as possible. So previously we had a mix between like AWS here, some on-premise services here, and now we've moved completely into Google Cloud, which gives us loads of options for flexibility. And the last point I had was real continuous delivery. What does that mean? Well, like I said, every team is responsible for doing their own tech, for building their own pipelines. So real continuous delivery really depends on who you ask. But I want to tell you how we do it in the team I work on. So I work on a team that builds something called Spotify Connect. And this is a service, a feature in the app that allows you to transfer music from one device to another device, like to your TV or to your Sonos speakers or something, and to control it. So all of your devices act as a remote control for the device that's playing music. And I work on the infrastructure team for that. So to give you an idea of like some of the challenges we have there, we have 180 million monthly active users, and we need to store their playing state, like what songs are they playing, what songs are they playing next, are they shuffling, are they not shuffling, and we need to make sure that that gets distributed onto all of their devices that are observing whichever device is playing music. And we need to make sure that that's accurate and that it's distributed properly, and that other services, like, for example, web APIs, can access that whenever they want, and that it's accurate. So to do this, the reason I'm talking about this is because I want to tell you a bit about the continuous delivery pipeline that we've set up to support this service. And I wanted to define some goals that we have for this pipeline, because a continuous delivery in itself is not a goal, right? You don't aim to have continuous delivery. You aim to get some value out of it. It's like a tool. So I wanted to talk about some of the goals we have that we want to get out of using continuous delivery for this. So I've listed some of them. We want to, of course, automatically trigger deploys after each merge. We don't want to have any sort of manual interaction there. That's pretty standard. We don't want any unnecessary manual intervention. We don't want to post-merge, like package up a service and then have to go and manually press a little button that says, I want to deploy this. And that's just so many extra steps that makes things slower. We also don't want to have a staging environment for this. In general, staging environments that we've had in the past have always not been so great to work with, because you always have the problem where you have to spend time making the staging environment reflect the production environment. So then you're spending time working on a staging environment that you use to verify builds before they go into production. But instead, you could be spending time working on tests so that you don't need a staging environment at all. So I think that's what we started shifting our focus on, at least in Connect, for the Connect infrastructure. We focused on making the tests better so that we don't need a staging environment at all. And lastly, we want really, really quick feedback times. Because we do a lot of experiments across the company, but also especially in my team, we like to deploy things really, really quickly and get really, really fast feedback on whether the work we're doing is good or not. So we want the deploys to go really, really fast so that we don't have to context switch away from what we're doing to work on something else while that is deploying. So ideally, we want the turnaround time from merge to it being in production to be like 10 or 15 minutes or something, so that we can continue working on that without having to switch focus. So to give you an idea of how that works, I'm going to show you part of the pipeline we use. It's pretty simple. It of course starts with a merge, as every post-merge pipeline does. So once we merge in GitHub, it's like you have like a basic post commit hook that triggers something that triggers like your post commit pipeline in Jenkins. And then Jenkins will spawn off a number of different pipelines, like just to build your container so that it's ready for testing. And then it goes into the testing phase. So of course, there's like a number of different phases of testing we do for the services that we own. You have basic unit tests, first of all, You have some integration tests that use stubbed upstreams, like mocked upstreams. But then you also have some integration tests that use production upstreams. And then we've also been experimenting a lot with like a system tests layer as well, specifically for Spotify Connect. And I wanted to talk about that a little bit because I think it's kind of cool. So if you imagine that you have a service A and that's under test, and it has upstream dependencies on service B and C. If you run an integration test that you want to hit production versions of B and C, it's pretty simple. That's how it works. But what this doesn't test is how the services that depend on service A will be affected by this new version of service A going into production. So it doesn't really check this, how like service D, for example, will be affected with this new version of service A in production. So we've been thinking a little bit about system tests for this. Ideally, I mean, if this was a huge problem, then you would maybe start thinking about contract testing or something. The reason we're not doing that is because, first of all, it's not a big enough problem, and also because then you'd have to sort of shackle all of the teams into this contract testing environment that we want to keep people, as much as possible, keep people free to iterate on what their team is focused on, rather than having to constantly come back to this contract. And so what we've done is something like this. So every service will have their own integration tests anyway, and this just tests how that service integrates with the rest of the services in the system. So when we have a new version of service A, like a snapshot version of service A, we spin it up in Jenkins. So it's now running. The whole service is running in Jenkins, and now we can start testing it. So the first thing that this system test pipeline does is that it gets a test user from a test user pool. So this is another service, a test user pool service, and it's responsible for owning a number of different test users, like actual Spotify users, that are set up specifically for testing. And you can request a user from it, and then you get the user, and you're free to use it for 10 minutes or something. So we call the test user pool service, and we get back like a user, like user X, for example. And then we start running integration tests. So these are tests that are making actual calls, like from the perspective of a user, from user X specifically. So these make calls into all of the like upstream services, and we run all of the integration tests from every service. So service A's integration test, B, C, and D. So you can see that service D is calling service A, which is in production. And what we actually have done is to get the production version of service A to redirect all of the traffic it receives for user X down into the new version of service A that's running in Jenkins. So this way, all of the integration tests that are written in service D, when they call into service A, they'll actually be hitting the version of service A that's running in Jenkins that contains the new code that we want to merge. So like what's actually happening is that we are sort of shadowing service A in production. It's not handling any of the production traffic for user X. All of that is being handled by the Jenkins, by the version of service A that's running in Jenkins. And this catches problems where this service A snapshot like invalidates some of the assumptions that are being made about it upstream by service D, for example. And I think that's quite powerful. Well, moving on, like after we run all of those tests and pass all of the tests, then we like create a version of the container that's ready to be deployed. And then we start deploying it using Helios into a Canary group. So we have this Canary group that's one host in each site. So we have sites, for example, in the US and in the EU, with a number of machines on them for each service. And we have one machine on each of those sites that's considered a Canary host. So when you have a new version of the service that's going to be deployed, that host is the one that gets that version of the service first. And then we want to make sure that when it's in production, that it doesn't break any more than the other versions of the production versions of the service that are running on all of the rest of the hosts. But like I said, we don't want to have any manual intervention. So we don't want to have to look at the graphs after we do a deploy and sit there and think like, how well is the Canary host doing versus the production hosts or the non-Canary hosts. So of course we built a service that will do that for us. So we have this service called Canary Analysis, and it pings us in Slack, which is pretty cool. So when we merge a new version of the service, it will ping us in Slack and say, I'm going to start analysis of my amazing service. And it's going to do this analysis for maybe 10 minutes. And what it's actually doing is constantly checking the Canary version of the service versus the rest of them in production, and comparing some key metrics that we've defined to see if the Canary host is doing worse than the non-Canary hosts. So if it finds some issues, it will ping us again and say, my tests for this service are failing, and then I'm going to roll it back soon if it doesn't recover. And the problems it said is that in Site 2, which could be like the EU, for example, the metric, some error ratio metric increased from 0% to 2%. And that could be like a ratio of 500 to 200 response codes or something. And if that doesn't recover over the next few minutes, then it pings again and says, the checks that they failed too much, so I'm going to roll it back. And the reason was that the error ratio in that site continued to increase. But hopefully that doesn't happen, and we get that all of the checks for this service have gone green, and it's going to continue to roll it out, and that they've all remained at 0% for all sites. And that takes us on to the deployment stage, and then we start. Once that Canary Analysis service has concluded that the Canary hosts are fine, it just automatically starts deploying past the Canaries into all of the hosts in production. And like I said, we want this to be really fast, so the Canary Analysis tool doesn't really run for that long. It's just long enough so that we're confident that the new version is fine. It's already passed all of the tests as well. So the turnaround time then from merging, running all the tests in Jenkins, running the Canary Analysis tool, and then rolling the whole way out to production shouldn't really be more than like 10 or 15 minutes or something. But also the turnaround time from merging to realizing that the code that you merged is broken should be less than that. And it should also, you should only have to do any sort of manual interaction with that if something breaks, you should only have to do some manual interaction with that once the production version of the service has been made safe. So it will have rolled it back automatically, and then it will tell you something broke, I rolled it back, everything's safe now. Now you should start some manual investigation to see what went wrong. But of course, sometimes this doesn't work. Sometimes things slip through testing, or sometimes an upstream service breaks and things break in production. So of course, then you still have like constant alerts. So somebody's always on call for each team, and we have like quite detailed metrics defined for each of the services that we have as well. But this also isn't even the last stage in the testing either, because we make very heavy use of A/B testing framework that we have internally as well. So we have this A/B testing framework that has every test that's currently running defined in it. And this could be a super simple test that we just want to check that this new refactoring, we just want to roll out this new refactoring that we've made slowly. So we roll it out to 100% of our hosts, but it's hidden behind a flag that's maybe set to 0%. And then we can slowly start rolling that out and checking the metrics if it's like a change that we're worried about. Yeah, but then if it gets to that stage where we have problems with deployments, it's too late, you're already affecting users. So that's when it gets a bit more serious and you get alerted, woken up in the middle of the night or whatever, and you have to do some manual changes. And generally what we do there is make things safe. So it's usually like a rollback or something. Yeah, so this talk was, I tried to talk about a couple of different things. I wanted to talk about how we organize our teams, like so that every team is autonomous, so that they can continue to iterate on whatever it is that that team's focus is on, and they don't have to be like restricted by any of the like overarching tech requirements of the company. They can sort of iterate and tune their systems to work well for them. I also talked about the history we've had going from 2006 when we had like Debian packaging things into Debian packages so that they could be deployed manually, onto now where we're moving into GKE, like everything's in Google Cloud and everything is like quite snappy turnaround times for deploys. And I also gave you an example of how we do deploys for my team, the team that builds Spotify Connect. Thank you very much.